Okay, so this is our mouse trap. These are the axles, and then these are the wheels, and then this is what actually powers it, the mouse trap and the rope. When you set the mouse trap, it creates tension in the rope, which creates potential energy. And then when it is released and the car starts to move, it is turned into kinetic energy. And what we did is I drilled 4 holes into the mouse trap and put in these eye sockets and stuck the axles into them and loosened to them to where they could turn enough to get motion, like so.
So to address the problems of the friction on our axles, we decided that the edges of the disc, the holes right here, were too smooth, and the pen that we used was really smooth. So we used rubber balloons to create friction so that the wheel, the disc, which we use as a wheel, doesn't just bounce around. And it's on there nice and tight, and so that pen itself will just move as the axle and the wheels will turn with it. To address the traction problem, the disc we use as wheels, the outer edges are really smooth as well, so it wasn't gaining traction. So we just cut up our balloons and we wrapped them around the wheels so that the rubber from the balloons can create traction because they're much rougher than the edge of the disc. And then we have Newton's third law, where for every reaction there's an opposite and equal reaction. Our lever, which is our mouse trap, would come back like this, and attached to it is a string that's connected to the back axle. So when the trap goes down, the string will unwind, sending the car this way, and the reaction sends it that way when the trap goes down. Let's see. Alright, stop.
Yep.
The lever arm itself with the spring we left alone because we felt that the trap provided enough pressure to where we didn't, enough power to where we didn't already need to adjust it at all. And then the spring itself and the trap does work on the axles and the wheels, which makes the car go forward because the trap and the spring is what does work.